Good afternoon and welcome to Thursday. Oh, you guys have a long weekend. Isn't that so fantastic? Yay. Have fun, everyone. And while you're there, while you're having fun, you can also have some fun with some math practice. Here's what it looks like for today. So the first type of practice we have has to do with Vertex Form over there behind me. So you can look at your notes for Vertex Form. Here, if I'm given this parabola and I want to know which one of these most closely relates to that parabola, I'm going to say, well, I have these parabolas listed in factored form. The factored form shows me the roots. I see a root there at -4 and a root there at -3. So I'm actually looking for this one, +4, +3, because I remember that I have to flip these numbers. Why is that? When I put in -4 here, the y value is going to be 0 because -4 plus 4 is 0. Anything times 0 times something else is 0. So that one is correct. It's also not this one because that has a positive value of a. That would be a parabola opening upwards. So I can very quickly tell that it's this one. Submit answer, yes, and it says correct. And then I look down here and they have the intercept factored form of a quadratic function is y is equal to a multiplied by x minus p times x minus q. Is anyone going to be confused when delta math calls these p and q, and they're the x-intercepts p and q, and I called them r and s, and the PowerPoint called them like, I don't know, quark and zork. It doesn't matter what you call them. They're just letters, all right? The letters stand for a number I don't know yet. So you want to just look at it and make a connection between what we did and what we just talked about. A is negative because the graph opens downwards. So that's what I talked about. Since the x-intercepts are -4 and -3, look at what they show you here. Oh my goodness, that's so useful. X minus -4 is x plus 4. X minus -3 is x plus 3. So it's great. All right, so that's how you're going to do those. Let's look at one more example. Good, one that opens upwards. But I want one where the roots are farther away. There we go. So here you go, -6, -1. So I'm looking for this one, +6, +1. This parabola opens upwards. That's it. Submit answer, yes. Yay! Okay, now the next type of information that we're looking for is vertex form coefficients. Here is a problem where we've been given a variety of parabolas now in vertex form. And we remember that vertex form, it has to do with the point of the vertex. So that's the point -6, -5. Sorry, -5, -6, because the x value, we talk about them first. Now, if we look for that, I see x plus 5, x plus 6. I want -6. X plus 5, x minus 6. There it is. That's my vertex form for this one. Why? Well, let's take a look at their explanation. Notice they use H and K. I use H and K. H and K is pretty standard. In terms of talking about the roots, I already explained this is my second favorite way to talk about the roots because it has R and S. They're roots, so I like R. I like R1 and R2 because there can be two roots. But here we use R and S because R1 and R2 confuses people sometimes. Okay, so here, this is the form of the vertex form of a quadratic. Okay, a times x minus h squared plus k. The vertex is at h and k, so that would be there. But I have to remember to flip the sign of the x value. The parabola opens upwards, our a value is positive, yeah, so here, and they show you the flipping of the sign, so it's very nice. All right, so you're going to learn to read vertex form here, and then determine the intercepts from factored form. So here, I want to be able to also look at this type of question and say, where does this parabola touch the y-axis? Sorry, the x-axis. Where does this parabola touch the x-axis? So I would look at that and I would say, well, looks to me like 2 is a good choice because if I put a 2 in there for x, y would be 0. And -3 is a good choice because if I put -3 in there for x, y would be 0. So the answer is this one. Submit answer, yes. No, really? Why? The y. Determine the y-intercept of the following equation. Read the questions carefully, Mr. Jennings. Okay, so let's keep going. Determine the x-intercepts of the following equation. All right, so we're looking for an x-intercept. They threw me because I didn't see that it was a y-intercept we were looking for. Here, this one is a little annoying because they've given you a negative x. So I can notice that I'm flipping the sign of this x. So I actually want 5, 0. That would be one of my zeros. And here, minus x minus 2. This is really annoying. But still, 5 and negative 2 would do it. I'm looking at it, and actually, it's annoying, but it forces you to think about what we've been talking about today, which means if I put 5 in, that would produce a 0. If I put negative 2 in, that would be negative, negative 2. That would be positive 2. Positive 2 minus 2 is a 0. That's the right answer. This time 100%. Yay. Okay. So now, let me show you how to answer one of the y-intercept questions. I honestly didn't know that there were y-intercept questions in here, but here we can find the y-intercept. To find the y-intercept, take this, multiply it by that. And that will give you your y-intercept. Here, the y-intercept is not 12, 0. It's 0, 12. There it is. Submit answer. Yes. Multiply this by this. And that will give you the y-intercept. And those are the problem types that we have for Delta Math today. This one is more practice graphing the equations. So here I have x squared minus 12x minus 35, and I want to graph it. And I have to graph the roots and the vertex. So we're just getting more practice on graphing parabolas here. So here, this is a parabola that opens downwards. It's crossing the y-axis negatively, and it crosses at negative 35. So it's going to be way down there, growing, crossing, and coming down. So I'm going to test values somewhere in and around this range. And it's really looking like minus 5 might be a good one because we have negative 35 there. So let's take a look at it. Negative x squared, so negative 5 squared is positive 25. But then I'm going to make that negative. So negative 25 minus 12 times negative 5. Negative 12 times negative 5 is positive 60. So 60 minus 25 is 35. 35 minus 35 is 0. So 5 was indeed a 0. Okay, let's take a look, see if we can find another one. Let's test 4 and see what happens at negative 4. Negative 4 squared. Negative 4 squared is negative 16 minus, this is plus 48. Negative 16 plus 48, I'm testing this point here, minus 4, is negative 16 plus 48 is 32. 32 minus 35 is down there. And so this parabola looks like this. Negative 7 will also be a 0. So negative 7 squared is negative 49 plus 84. Negative 49 plus 84 gives me 35. Yeah, there it is. That's a 0. And then I plot one more point. I just plot that one symmetrical around the axis of symmetry, and then I'm ready to go. And I say submit answer. Yes. No, I was not right. Why was I not right? Huh? Boop, boop. Oh, I never specified the roots. Oh, I forgot. I should have selected 2 numbers for the roots because the graph crosses the x-axis at 2 distinct locations. I graphed it correctly. I just forgot that I have to then state the properties. I wasn't reading the question carefully again. So the lesson today is read the question carefully. And I hope that your Delta Math practice is fruitful. And with any questions, definitely come and find me.